when any solid is heated, it can emit radiations of a wide range of wavelengths. Now, whenever any object or a solid is heated, whatever the radiations it is emitting out are called hot body radiations. Now, these radiations emitted out varies with the temperature to which it is heated. Like, let us take an example of an iron rod, which when heated to a low temperature remains black in color or in metallic color. When heated to further high temperature, it becomes what? It starts glowing, it becomes torch. The color emitted out varies from red to then yellow, and when taken to a very, very high temperature, it becomes blue. So whatever the colors which that metal rod, iron rod is emitting out are called, the radiation which are given out are called hot body radiations. Similarly, what is actually this black body is? See, any object or a solid body which can absorb and emit all types of frequencies or radiations is called black body. And the radiations which are emitted out by the black bodies are called black body radiations. Now, these two concepts can only be explained by considering particle nature of the EM radiations. Planck was the first one who explained them with the particle nature of the EM radiations, and on the basis of this he said that these radiations which are given out, emitted out by hot body and black body are completely given out or emitted out discretely in the form of small packets of energy which are called quanta or quantum, which particularly for light are called photons. And which what we have already done, like the energy of these photons or the quantas or quantum are basically directly proportional to the frequency of the radiation, and this is how we got the Planck's constant in this equation, which is E is equal to h nu. So this is the black body and hot body radiations example, which can only be explained by considering the particle nature of the EM radiations.